Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Astronomers are reporting their observation of the so-called brightest and furthest pulsar ever observed from Earth, using data from the European Space Agency's XMM Newton satellite. The supposed spinning, magnetized neutron star presents a major challenge to the consensus ideas about such theoretical objects. Identified as NGC 5907X1, the quote pulsar appears to shine with a brightness that is 1,000 times greater than the object's theoretical limit. To gain a perspective on just how stupendously bright the pulsar appears to be, a phys.org report states, in 1 second, it emits the same amount of energy released by our sun in 3.5 years. As the lead author of a paper on the object states, this object is really challenging our current understanding of the accretion process for high-luminosity stars. It is 1,000 times more luminous than the maximum thought possible for an accreting neutron star, so something else is needed in our models in order to account for the enormous amount of energy released by the object. The mystery for investigators is not simply the object's brightness, but also the speed at which the quote pulsar's alleged spin rate increased over a period of 11 years. As phys.org reports, the same relative acceleration in Earth's rotation would shorten a day by 5 hours in the same time span. What is a so-called neutron star? Scientists tell us that the material left over from a supernova explosion of a massive star collapses gravitationally, forming an incredibly small, yet massively dense star mostly composed of tightly packed neutrons. A rotating neutron star is said to emit regular pulses of radio waves and other sources of radiation, called pulsars. But the hypothesis of the neutron star was not a predictive theory that was composed and then verified through observation. Rather, the hypothesis was invented in the 1960s, after the completely unexpected discovery of radio pulses from the constellation Vulpecula. In 1968, it was the world-renowned astrophysicist Thomas Gold who proposed that the source of the pulses was a rapidly rotating star acting very much like a lighthouse, with the light beams becoming visible on Earth with each resolution of the star. The extraordinary speed with which such an object is said to rotate is sometimes many times faster than a dentist's drill. However, in recent years, with finer technological data has come numerous discoveries that in effect falsify the neutron star hypothesis. As reported in previous Space News episodes, this is not the first instance that a so-called pulsar's apparent brightness has exponentially exceeded its theoretical limits. Other behaviors have proved equally puzzling, including the discovery reported in 2013 of a pulsar that switches suddenly and unpredictably between radio and X-ray emissions. The lead author of a paper on that discovery said at the time, "The people creating models will have to rethink what we are discovering here. When we look now to what is so far published in papers, nothing at this moment can explain what is happening." But is the hypothesis of a mechanically spinning lighthouse of sorts really the only explanation for pulsars? If a crisis in cosmology exists, is it a coincidence that institutional science continues to try to explain stupendous electromagnetic phenomena through purely gravitational mechanisms? In the case of so-called neutron stars and pulsars, the disciplines of plasma physics and electrical engineering do offer theoretical alternatives. It has been suggested that a more useful analogy to pulsar flashes is the complex radio signals induced in Earth's ionosphere by powerful lightning. This clue could help to explain the evidence, inexplicable in the standard model, of pulsars switching from radio to X-ray emissions, since lightning can produce both. In fact, scientists attempting to explain this puzzling switching of emissions are considering changes in the star's magnetosphere, which does bring them closer to the electrical interpretation. In fact, in 1995, the renowned plasma physicist Anthony Peratt and co-author Kevin Healy published the paper Radiation Properties of Pulsar Magnetospheres, Observation, Theory, and Experiment. Peratt and Healy examined well over a dozen pulsar anomalies yet to be explained by the standard lighthouse model. They state, "There yet exists no self-consistent theory to describe the pulsar electrodynamics." Using electromagnetic particle and cell simulations, the team investigated a, quote, magnetospheric disk field-aligned current transmission line system as the origin of the observed radiation, with external wave excitation by as yet an unexplained source. This model does not require a rotating object or the lighthouse effect. Rather, it in effect states that an electrical discharge occurs close to a star, which then travels along the magnetic field lines outwards, where it meets a disk of matter surrounding the star. Where it meets that more dense matter, a kind of short circuit occurs, and the signal is reflected, as in transmission lines in electrical engineering theory. In fact, in a Space News interview, retired professor Dr. Donald Scott has suggested that the ideal analogy for a pulsar's flashes is not a lighthouse, but rather a strobe light. A strobe light is a small ball containing a plasma, driven by a simple electrical circuit. As seen in this picture, it can consist of nothing more than a resistor, a capacitor, the voltage source, and a glass tube. In the 2015 Space News, The Invention of the Neutron Star, Professor Scott explained the analogy in space as follows.
If we have a pair of stars, a binary pair of stars out in space, and if they're closely spaced, there may very well be a plasma bridge between them. And the resistance in the relaxation oscillator is the resistance of that plasma bridge. And so the capacitance value depends on the surface areas of the two stars. And if one of the stars is being driven by an external current to a higher and higher voltage, clearly this kind of oscillation is possible. Also, voltage pulses can bounce back and forth along a plasma bridge. If we have a plasma bridge that connects the two stars and we get a voltage pulse that goes from one to the other, it can bounce back again, and there's all sorts of possibilities for reflections of pulses on high voltage power transmission lines.
But in institutional science today, theorists seeking to gain a better understanding of, quote, neutron stars tend not to be specialists in electrical engineering and plasma physics. Always, the assumption is that the detected light pulses are produced by spinning, magnetized neutron stars, even though said objects remain entirely hypothetical, and the predictive record of the hypothesis grows increasingly poor. The mantra of self-styled skeptics is that extraordinary claims require extraordinary evidence. Astrophysicists freely acknowledge that the neutron star, if it exists, would be one of the most exotic objects in the known universe. But an ongoing series of theory-shattering discoveries have transformed the neutron star hypothesis from exotic to extraordinary to perhaps impossible. However, as in countless other fields of space science discovery, real alternatives await in our electric universe. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.